You've seen the videos. A KamAZ truck built in 1978, grinding through Siberian mud with 3 blown head gaskets, the engine still running after almost 5 decades. And on the other side of the internet, a 2024 Freightliner sitting in a service bay, sidelined by a single contaminated diesel exhaust fluid sample. 2 trucks. One designed during the Soviet Union, one designed last year. The old one runs, the new one doesn't. And the obvious explanation feels like a punchline. Russian engineering is better. Americans build disposable garbage, right? But that's not actually the reason. The real answer is much stranger, much older, and frankly a little embarrassing once you see it. This is not a story about engineering quality. It is a story about 2 countries that asked completely different questions, got completely different trucks, and built 2 completely different versions of your daily life on top of those answers. The system you are about to learn about is hiding inside something you ate this morning, something in your refrigerator right now, and the price you paid at the grocery store last week. This system reaches from remote repair shops to emissions rules to the very parts that keep a truck running. By the end of this, you will see exactly how a 1976 truck design quietly shaped the cheapest jar of pasta sauce on your shelf. But let's start with what everyone gets wrong. The first explanation people reach for is the obvious one. American trucks are over-engineered. Too many computers, too many sensors. And to be fair, that explanation is not wrong. It is just incomplete. Here is what actually happened. Between 2007 and 2010, the Environmental Protection Agency, EPA, rewrote what an American diesel truck was allowed to be. In 2007, every new heavy-duty diesel was required to have a diesel particulate filter, a device that traps soot in the exhaust and then burns it off in cycles called regenerations. In 2010, the rules tightened again. Every new truck then required a selective catalytic reduction system, which sprays a urea solution called diesel exhaust fluid into the exhaust to chemically neutralize nitrogen oxides. On paper, this is climate progress. In the service bay, this is chaos. Diagnostic data from FKR Tech shows that since 2007, roughly 60% of all aftertreatment-related repairs on American trucks involve the regen system. The selective catalytic reduction system fails more often than any other powertrain-related component on a modern truck. Nothing breaks more than the system designed to clean the exhaust. But the math gets worse. The legendary KamAZ 5.9-liter diesel, the engine that routinely went 1,000,000 miles before needing a major rebuild, was killed in 2007. It was replaced by the 6.7-liter, specifically because the 5.9-liter could not be made to comply. And the replacement is not a downgrade in capability, it is an upgrade in fragility. The CP4 high-pressure injection pump on 2019 and later 6.7-liter engines can fail catastrophically and contaminate the entire fuel system. A single failure costs over $10,000 to repair. So a modern American semi is not just a vehicle. It is a rolling computer network with dozens of electronic control units. A single bad sensor reading can trigger limp mode and strand a fully loaded 80,000-pound rig in the middle of an interstate. But blaming emissions misses the bigger truth. Russian trucks did not outlive American trucks because Russia avoided emissions rules. They outlived them because they were never trying to be the same thing in the first place. Here is what nobody mentions. The KamAZ in that Siberian mud video was not designed to last 50 years because Russian engineers were better. It was designed to last 50 years because failing was not an option, and replacement was not available. That is a completely different engineering brief. Look at the engine that ran most Soviet-era heavy trucks, the KamAZ 740 V8. It has 10.85 liters of displacement, and it makes about 210 horsepower. This truck was built for survival. Read that again. A 10.85-liter engine making 210 horsepower. A modern American KamAZ 6.7-liter pulls more than 500 horsepower out of a smaller engine. The KamAZ engine is intentionally, almost aggressively, understressed, wider tolerances, more forgiving combustion, less heat, less wear. The mechanical equivalent of someone who jogs slowly forever, instead of sprinting once. But here's where it gets stranger. The ZIL-131, one of the most common Soviet trucks ever built, was designed to operate from minus 55 degrees Celsius all the way up to plus 55 degrees Celsius. That's a 110-degree operating range, and the truck has to start, run, and hit the road in any of it. To pull that off, Soviet engineers built engines with mechanical tolerances so wide that thick lubricants still flowed through them. Western engineers building tighter, more efficient engines literally couldn't have done that. The tolerances would have starved the bearings. And then there's the part that should make American truckers stop scrolling. Over 60% of the components on the military ZIL-131 are identical to the civilian ZIL-130. Same parts, same tools, same repair procedures. A Soviet farm worker fixing a grain truck and a Soviet conscript fixing an artillery transporter were doing essentially the same job with the same wrenches. American trucks aren't designed that way. A modern American semi requires dealer-level proprietary diagnostic equipment to even read why the engine derated itself. And this connects directly to something sitting on your kitchen counter right now. But we'll get there. Because the real reason these two philosophies exist isn't actually about engineering at all. It's about geography. On December 13th, 1969, the Soviet government broke ground on the largest truck plant in the world along the Kama River, in a town called Naberezhnye Chelny. The location was chosen because it lay deep inside Russian territory, where no enemy could easily bomb it, and because the engineers who designed the plant worked with full input from Soviet military command. The decision to build the plant was strategic. The first KamAZ rolled off the line in 1976. By 1988, KamAZ trucks made up roughly 1/3 of all trucks in the entire USSR and carried 2/3 of the country's road cargo. The truck was not a product, it was infrastructure. But here's the part that explains everything. The truck had to work in the Russian Arctic. To this day, the Russian Ministry of Defense uses a specialized Arctic diesel fuel with a cold filter plugging point of minus 65 degrees Celsius, no additives needed. Russian military M3Z12D engine oil allows engine starts at minus 50 degrees Celsius without any preheating. And the original design assumption, the one that haunts every Soviet-era spec sheet, was brutal. If your truck breaks down 2,000 kilometers from the nearest dealer, in a snowstorm, at minus 50 degrees Celsius, you are not going to be rescued. There is no AAA. There is no roadside assistance. The truck either has parts you can replace by hand, or you die in it. American trucks were designed under the opposite assumption. If your Freightliner breaks down anywhere in the continental United States, you are statistically less than 30 minutes from a dealer. Therefore, complexity is affordable. Computers are affordable. Sensors that lock the engine into limp mode are affordable because limp mode just means a tow, and a tow is 15 miles. The most absurd historical detail of all. In the early Soviet era, drivers in deep cold would actually drain the oil out of their engines overnight and bring it indoors to keep it warm, then pour it back in before starting the next morning. That was not a quirky tradition. That was the actual procedure. You think this is a story about Russian and American trucks? It is not. It is a story about every product on every shelf you have ever touched. Here's how you know. After 2007, when the new emissions rules hit, something extraordinary happened. American truckers wanted the old engines so badly, the KamAZ, Detroit, and Caterpillar engines built before 2007, that they built an entire underground industry around resurrecting them. It is called the glider kit business. A glider kit is a brand new truck body and frame sold without an engine. The buyer drops in a rebuilt engine built before 2007, registers the truck under the older engine year, and legally drives a brand new vehicle that does not have a single piece of modern emissions equipment on it. Fitzgerald Glider Kits, the largest player, was producing more than 3,500 glider trucks a year at their peak. And here is where the numbers get insane. According to the EPA's own analysis, 10,000 glider trucks emit as much fine particulate soot as approximately 200,000 new compliant trucks. That is a near year's worth of U.S. new truck sales in pollution from a few thousand vehicles. Glider trucks emit roughly 55 times more soot than a modern truck. The 2016 Phase 2 greenhouse gas rule capped each manufacturer at 300 glider trucks per year, effectively ending the loophole. American truckers, given the choice between a clean truck that breaks and a dirty truck that runs forever, chose the dirty truck so consistently that the EPA had to write a federal rule to stop them. And that trade-off is in your refrigerator right now. The strawberries that arrived from California in January, the insulin at the pharmacy, the Amazon package on your porch, the price of milk this week. Every single one of those things rode part of its journey on a truck somewhere on the spectrum between clean and fragile, and dirty and immortal. So here's where you actually land. You open this video thinking you were about to hear that Russian engineers are better than American engineers. You are not. What you were actually looking at was a 1969 Soviet decision to build trucks for a country with no dealer network, an Arctic operating range, and a military that needed every truck to be a backup tank. You were looking at an American regulatory environment that, between 2007 and 2010, asked the trucking industry to choose cleaner air over longer life. You were looking at a glider kit underground that rejected that trade-off so loudly the government had to legislate it shut. And you were looking at every grocery store, every pharmacy, every package on your porch, all sitting on top of that exact same trade-off every single day. Russian trucks last 50 years not because they are better. They last 50 years because they were never asked to do anything else. American trucks do not last 50 years because they were asked to be cleaner, faster, more comfortable, and replaceable. You are not looking at engineering failure. You are looking at two completely different theories of what a truck is, and your daily life sits on top of both of them. And if you think trucks are strange, wait until we get into why almost every modern engine in your driveway is quietly engineered to fail at exactly 200,000 miles.